In this lesson, we are going to learn about 6 trigonometric ratios, which includes the sine, cosine, tangent, cosecant, secant, and cotangent. What I've written in brackets represents a short form of each trigonometric ratio. For example, sine can also be written as sin, cosine, cos, tangent, tan. Cosecant can either be written as cosec or CSC. Secant is sec, and cotangent is cot. We can generate all these 6 trigonometric ratios from a right angle triangle. So we're going to create a right angle triangle here, then we generate all these ratios. To do that, I'll introduce an angle of 90 there. Then I'll have to introduce an angle theta. Angle theta can either be introduced here or introduced here. In this case, we are going to introduce the angle theta there. We're also going to use an acronym, SOHCAHTOA. And SOHCAHTOA is an acronym we use to generate the first 3 basic trigonometric ratios. That is the sine, cosine, and tangent. So simply means sine of theta is going to be opposite divided by the hypotenuse. And k means cosine of theta is going to be adjacent, you divide by the hypotenuse. And tan of theta is going to be opposite divided by the adjacent. So the first thing you need to do also is to ensure that we identify the opposite, adjacent, and hypotenuse of our right angle triangle. To do that, we can start with the first one, in which that side that is directly opposite the angle theta is going to be our opposite. And the side that is directly opposite the 90-degree angle is going to be the hypotenuse. And the side that connects the angle theta and the 90-degree angle is going to be our adjacent. Now, with all this information, using the SOHCAHTOA, we can generate the first 3 basic trigonometric ratios. That is the sine, cosine, and the tangent. Let us start with the first one. We are going to start with the sine of angle theta, which is going to be equal to, according to SOHCAHTOA, sine is opposite divided by hypotenuse. So you'll come to your triangle, identify your opposite, then you divide by the hypotenuse, divided by the hypotenuse. So this ratio you get is the sine of that angle in this triangle. The second ratio is going to be the cosine, and you're going to use the k part of the SOHCAHTOA. K means the cosine of angle theta is going to be equal to adjacent divided by hypotenuse. It's going to be adjacent divided by the hypotenuse. Adjacent divided by the hypotenuse. Then the third basic trigonometric ratio is going to be tan. So you're going to take the toa part of SOHCAHTOA, and this tells us that tan theta is going to be equal to the opposite over the adjacent. That is the opposite over the adjacent from your triangle. Over the adjacent from your triangle. And those are the first 3 basic trigonometric ratios. Now, how do we get the other 3 trigonometric ratios? Let us go to the 4th trigonometric ratios. To get the other 3 trigonometric ratios, that is cosec, sec, and cot, we find the reciprocal of the sine, cosine, and tangent respectively. So in this case, starting the first one, cosec of angle theta is going to be equal to the reciprocal of the sine, that is 1 over the sine theta. The 5th trigonometric ratio, which is going to be sec of angle theta, is going to be equal to the reciprocal of the cosine, that is 1 over the cosine of theta. And the last trigonometric ratio, which is going to be cot of angle theta, is going to be equal to the reciprocal of the tangent, that is 1 over the tan of angle theta. In case you find a challenge remembering this, there's the hack to help you remember. So I write the 3 trigonometric ratios, that is cosec, then I'll have the sec, and I'll have the cot. Now I want you to pay attention. Look at the third letter from left. The third letter from left in the first case is S, and that S will stand for the sine. So if you want to get the cosec of theta, it must be equal to 1 over the sine of that angle theta. For secant, I want you to pay attention to that letter from left. It is C. So to get the secant of theta must be equal to 1 over the cosine of theta. And for cot, look at the third letter from left is a t. And this one tells us that if you want to get the cot of theta must be equal to 1 over the tan theta. So the third letter of cosec, sec, and cot, they are going to help you to know what are you supposed to find as a reciprocal to find the ratio of corresponding cosec, sec, and cot. Let us look at an example to calculate these ratios using numbers. Let us look at this question. From the right-angled triangle provided below, calculate the following ratios: sine, cosine, tangent, secant, cosecant, and cotangent. So we'll start with the first three, which are the simplest, and we are going to use the acronym SOHCAHTOA. SOHCAHTOA. So the SOHCAHTOA will help us to generate the first three basic trigonometric ratios. So we start with the first one, the sine of angle theta, and according to SOHCAHTOA, the sine of angle theta will be equal to opposite divided by hypotenuse. So the opposite is going to be a 4 divided by the hypotenuse, which is going to be a 5. So that is the sine of angle theta. The second one will be the cosine of angle theta, and according to the SOHCAHTOA, cosine is equals to adjacent divided by hypotenuse. So adjacent is a 3 divided by the hypotenuse, which is a 5. And the third one, which is the tan of angle theta, is going to be equal to, now from the SOHCAHTOA, TOA means tan is opposite of adjacent. So opposite, which is a 4, divided by the adjacent, which is going to be a 3. So those are the first three basic trigonometric ratios from that triangle. We go to the fourth ratio, and there's going to be secant of angle theta. And secant, we look at the third letter, which is a C. And C is for cosine, which means that the secant of theta is going to be the reciprocal of cosine. So you come back to your cosine. If cosine is 3 out of 5, then the reciprocal of 3 out of 5 is going to be 5 out of 3. The fifth one is going to be cosec of angle theta, which is going to be equal to, look at the third letter. The third letter is an S, which means is a reciprocal of sine. So come and check where your sine is. 4 over 5 is your sine theta. So the reciprocal of 4 over 5 is 5 out of 4. The last ratio, that is ratio number 6, will be cot theta. And as you can see, the third letter is T, which means that to get the cot of theta, we have to find the reciprocal of tan. So you need to come back again, you find what was tan. So tan theta was 4 over 3. So to get the cot of theta, you reciprocate 4 over 3, and that is going to be 3 out of 4. And those are the 6 ratios from this right angle triangle. And that brings us to the end of this lesson. Hoping this video is going to be of help to you. And I say thank you for watching. Hoping to see you next time.